Hello there, it's Jason Gorman from Codemanship with the final video in our series on Python Codecraft. In this video, I'm going to be talking about continuous inspection. This is a fairly more advanced practice for teams who care about codecraft. And as the name implies, it's continuously inspecting our code for potential quality problems. Now, most teams these days do code reviews manually. It's a kind of manual testing. So they're looking for code quality problems or looking for instances of their code that doesn't follow, for example, their coding standards. And they're doing that by looking at the code, by reading the code, basically. And like all manual testing, that can become a bottleneck, number one. It takes a lot of time, and that can really slow down the development process. So, for example, if your policy is that on your team, you submit pull requests and your pull request can't be merged into the trunk, until someone else on your team has inspected and okayed your code, then there are a lot of teams out there who are sitting around twiddling their thumbs waiting for their pull request to be reviewed, and that can slow development down. How did we get rid of that bottleneck when it came to functional testing? Well, we automated our functional tests. So we wrote, for example, fast running unit tests so that we could run those tests very quickly, run them over and over again, and also to test exhaustively, which is another drawback of manual code reviews, is they're not particularly exhaustive, they're not particularly consistent. It really does depend on who's reviewing your code, how much time they've got, and so on and so forth. So there are a lot of teams out there who are doing what I call code review theatre, where they're kind of giving it a cursory glance, but they're not being particularly methodical or exhaustive about it, and that misses a lot of stuff, a lot of issues. So if you want really clean code, and you want your code to be maintainable all of the time, you want to be sure that anything that's getting checked into source control is maintainable, does meet your coding standards, then you need to think about automating your code reviews. And what I'm going to do is I'm going to demonstrate using a couple of different tools how you can do that in Python. First of all, I'm using PyCharm, one of my favorite editors for Python. I do like my tools. And one of the nice tools that we have in PyCharm is the ability to automatically inspect the code. So I'm going to select the folder that has all of the source files in it, here, all the Python source. And if I click on inspect and we run an inspection, and what we'll see here is that PyCharm is crunching its way very rapidly through thousands and thousands and thousands of lines of code. Now, no human being can review code at this speed, especially as you'll see for the number of different kind of code quality issues that it's looking for. It would be absolutely impossible. So it's very exhaustive and it's very fast, which means we can do it many, many times. So this might be something I would do, for example, before I was thinking about checking in, or it's something I might do on a regular basis, just to make sure that I haven't missed anything in terms of code quality or other kinds of things. And interesting, we've got some errors here. So let's take a look for these errors. You can see it's been through all of the code. A bunch of stuff there that I hadn't noticed before. Okay, so let's take a look and see what's going on here. Missing closing quote and well, that's that doesn't look too seriously, so we'll ignore that. Let's take a look in the Python code itself. A whole bunch of warnings here about access to protected members of classes or modules. Got to inherit all of the abstract methods and so on and so forth. So a whole bunch of stuff that we missed. This code base, by the way, is the code for a tool called Pylint, which is another tool that you can use for automatically inspecting Python code. So I thought it would be fun to run a code inspection on Pylint's code. So we've done this inspection. It's thrown up a whole bunch of issues, some of which I care about or agree with, some of which I might not care about or agree with that they're a problem. But we'll come to that in a minute. And you'll also notice that they have different kinds of severities, basically. So some of these things are errors, as in no, that's an absolute no-no. And some of these things are warnings, like maybe the policy there would be if you get a warning, someone else on the team then has to review it. And some of them are what they call weak warnings. That is, well, it's more kind of informational than anything else. You might want to take a look at this. So there's a kind of gradings of severity of the different kind of code quality problems that you might find using a tool like this. Now we can configure this tool so we don't have to take everything out of the box that it tells us we have to have. So let's look at Python's rules, for example, and there's a whole lot of them here. access to a protected member of a class or module, that's switched on. Access to properties, that's switched on. And we can switch these automated rules on and off. And we can also change the severity. So we can say, well, that's a warning, but I think it's an error, or that's just a weak warning or a typo or whatever. So we can sort of change the policy, if we like, or the severity of the feedback that we get. So we can customize our suite of different code quality checks so that we're getting feedback that we think is more relevant to us. It's stuff that we care about. You don't necessarily want to be searching for hundreds and hundreds of things. There's probably maybe a couple of dozen things that you genuinely care about. So you invest some time here to just go through there and decide, do we care about that? Do we not care about that? Do we think that's a really bad thing? We should say that's an error, or do we think that's just, not so sure, maybe, a bit of a warning. And we can run these, once we've configured these, we can run these checks as often as we like, because they're very, very fast, even on large code bases. So that, in essence, is what continuous inspection is. It's continuous automated code quality testing using a tool like the built-in code quality checker in PyCharm. Now, as I mentioned before, PyLint is another tool that is available, one that's very, very popular. I'm a big fan. And it's also very, very easy to use, as you're about to see. So let's have a go using PyLint. Let's get rid of this window here. And if I go to my terminal, let's install the PyLint tool. So just pip install PyLint, off we go, and that should install it with any luck, and off we go. There we go, successfully installed. And running PyLint against a code base is very, very easy. Basically, you just use the PyLint executable, the PyLint command there, and then you specify the name of a Python file or a Python module that you want it to inspect. In this case, we'll go for the root module. That's PyLint. So PyLint, there you go. That's why I did it on PyLint, because that's a nice little conceit there. Off it goes, and it's going to do a very similar thing to the tool that we looked at before. It's going to read the code, crunch its way through it, basically, and then start generating outputs, which we'll see here. It can write them to files as well, but we can also see the outputs being generated. Hopefully, off it goes. It's having a bit of a think. So it's crunching its way through all of the source code, just like the other tool was. It's got its own set of rules, of course. It's not the same rules that PyCharm has, and this is one of the things we need to talk about. One of the mistakes I see teams make when they sort of start to do continuous inspection is they get a tool like PyLint or something like that, and then they just take the rules that come out of the box as they are, the rules and the policies that come with the tool, and they just kind of put it in their build, for example, and go, there you go. But then it's coming up with a whole bunch of feedback. It says our code is 9.94% okay rated. It's flag up a bunch of options. We shouldn't be surprised that PyLint, on the whole, passes its own quality checks. If you're writing a code quality testing tool, I highly advise that you use the tool on its own code, because that's the first thing any developer is going to do, is go, oh, I wonder if it passes its own quality checks. The set of rules that come with PyLint are pretty decent, but again, I don't necessarily agree with all of them. So there needs to be a level of customization. And as with all linters, it's infinitely customizable as to which rules are switched on and off, as to the severity of the feedback you get for each of these rules. And on top of that, you can write your own custom rules. And that's very, very important, because it may well be that there are code quality standards that you agree on as a team are very important, but the tool just doesn't have them built in. So you can write your own code quality checkers in Python that can then be integrated and run by PyLint as part of your set of rules. That, of course, takes some investment. It doesn't come for free. To create a set of code quality rules that you all as a team agree with, that you all find useful, is going to require some considerable customization and a bit of trial and error as well. It's an iterative process, like all design. So you need to not just take it out of the box and not just customize it once, but you need to keep a close eye on it every week or every two. Just review the feedback you're getting from your code quality checks and ask yourself, could we improve that? Is it missing things? Are we getting false positives, things that we don't think are a problem? And then you kind of rinse and repeat, basically. You iterate, you refine your set of code quality checks. Now, this is something you can run on your desktop very, very easily, and it provides very useful feedback to you. And that's a very useful thing, because it means that you can be much more fastidious about the quality of your code. You can be running these checks many times a day if you want, and fixing the problems. But when you're working on a team, quite often you need a kind of a last line of defense as well. It's not just enough for people to check code quality on their desktops. You probably need to think about building code quality gates into your build process, into your continuous integration process. And a lot of teams are starting to do that now, using tools like Pylint, for example. And that sort of raises the stakes a little bit. You need to think a little bit harder about how you're managing this, because most organizations these days have many code bases and many build pipelines. So they have sort of a portfolio of different products, but they need to be keeping an eye on the quality of that. So the last tool that I'm going to show you is more a tool for managing this process of continuous inspection for teams or for organizations. And that's called SonarCube. You may well have heard of it. Your team may even be using it. SonarCube can integrate code quality checks and the reports that we get from those into a single sort of portal, if you like, from all sorts of different programming languages. Again, it's, as we'll see, it's totally customizable. So here's my dashboard for a bunch of projects. I'm afraid there's not a Python one on here, but you can see there's a C# one, there's some JavaScript, some Java, and so on and so forth. So this could be your portfolio of software projects or products, each with its own build pipeline, and as part of those build pipelines, it would be running code quality checks and generating these reports. And we can take a look at how we can customize quality profiles. So for example, here's one that I've set up, the Codemanship way, which is a customized version of our C# profile. So we've got a whole bunch of active rules here and inactive rules, and we can have customized rules, and it's telling us what rules we've got active, and what kind of a rule is it? Is it a code smell? Is it a security problem? And so on and so forth. And we can customize those rules if we want to, and we can also, again, using tools like Pylint, incorporate our own customized rules into those reports. And we can also set up quality gates. So now this is the policy, is to, based on the output, based on the feedback we get from that code quality check, what do we do? So a quality gate essentially defines a set of criteria for whether it's a pass or a fail. And you might, for example, have a policy that says, look, if it fails to get through the quality gate, then essentially we fail the build, we reject that check-in. So it's the equivalent of a pull request review, if you like. It's a similar kind of idea, but completely automated. Now, just because it's automated, that doesn't necessarily mean that there is no place for people getting around a laptop or a projector and reviewing code. So just as it is with automated tests, you've got to ask, well, what about the test cases we didn't think of? Now, in functional testing, we have this practice called exploratory testing, where a tester, for example, or a developer will sit down with the code, with the application, and essentially play with it and ask questions like, but what happens if I press the back button in the browser, and that kind of thing. So they're exploring and saying, okay, outside of the tests that we thought of, the tests that we automated, and what didn't we think of, what haven't we spotted? And team code reviews are a bit like that. In a continuous inspection process, in continuous automated code review, there is definitely a place for regular manual code reviews, for the team to get together, maybe as part of a mob programming exercise, get round real code and review that code and talk about what are we missing here, basically. What are we not checking for? And then on an ongoing basis, incorporate those new checks into your quality gates, so that as time goes on, your quality gates become more effective. Now, that all is quite the investment, and it's why there are still many teams who don't do it. They're not willing to make that kind of investment in time. And up front, I won't lie to you, it does take quite a lot of time. And particularly if you're writing customized code rules, there's a specific skill set involved that takes some time to learn. It is definitely worth it. It's definitely worth making that investment, but not possibly just for the one project or the one product or the one-off for a 3-month effort, for example, because this investment can be reused. If you invest in continuous inspection for one Python product or Python project, that many of those code checks could be reused in builds, as quality gates in build pipelines for new Python projects. So after a while, you can invest less. Basically, after a while, you become comfortable with the quality gates that you've got, and they only need to be tweaked a little bit on each project or for each team. So it's definitely an investment worth making. It is the route to genuinely clean code. The teams that are writing the most maintainable code that I've seen are all doing some kind of continuous inspection. Pair programming is great. Mob programming is great. Code reviews are very useful for coming to a consensus about what we think is good or bad or better or worse and what we should be checking for. But if you want to be 99.4%, as our report said, sure that your code is up to scratch, then continuous inspection is a practice you really do need to look at. So there you go. That's continuous inspection in Python. I hope that's been of use, as have all of the videos in this series. And if you're interested in codemanship training, we don't just do videos. I'm a real person, a real trainer. It's all remote at the moment, of course, but just as effective. Then visit codemanship.com to find out more.